first keynote speaker is currently serving as a senior lecturer at the University of Colombo School of Computing. He has also been a former director of UCSC and a Fulbright senior visiting scholar at Carnegie Mellon University's Language Technology Institute in Pittsburgh, USA. He has served on various committees and boards at the University Grants Commission, Ministries of Education and Higher Education, the National Science Foundation, and the Information and Communication Technology Agency of Sri Lanka. His research interests are in computational linguistics, including machine translation, and particularly in techniques employing statistical methods and machine learning using large data sets. He led the UCSC's Language Technology Research Lab from 2004 till 2018. It is with great anticipation that we introduce our distinguished keynote speaker, who will unravel the fascinating realm of AI hallucination in his address titled When Machines Go Rogue: The Risks and Reward of AI Hallucination. Brace yourselves for an enlightening journey into the future of AI, where opportunities and challenges collide. Please join us in extending a warm welcome to University of Colombo's very own Dr. Ruwan Weerasinghe.
Thank you very much, and it's great to be here, Ambassador. Many thanks for the support of your government, and hopefully you can see the result of this. We have audience from all universities, and many of those universities are served by former graduates from the UCSC. The Vice Chancellor, Acting Vice Chancellor and Registrar, the members of the companies that are sponsoring. I hope you see that the program that we have is kind of a thing that will bring you better talent in the future. And of course, my colleagues at UCSC and dear students from all across the country. I know some of you have come very early, come from quite far, or even yesterday. Thank you for being here. So as the conference organizers, they wanted, everybody is talking about generative AI and how great it is and so on. So they thought we should do something a bit different, and particularly to make the next generation probably more responsible than us. So the topic is about AI hallucination. I just, of course, the organizers are very keen to say that this is a place where you participate. Unfortunately, in a keynote, it's a bit difficult to participate, but I want to just have an initial kind of show of hands. How many of you recognize at least two people in this group of faces? Two people. Okay, there are a few, right? At least there are some computing people in this. The second question is, of course, what brings them together? What can possibly bring such a diverse group of people together? That's what I'm going to just present in the next few slides. And this, of course, is one of the most famous self-portraits of Vincent van Gogh. And a person who was not recognized, of course, during his time, because probably people thought he was hallucinating. Our own field, one of the fathers of our own field, Alan Turing, not only because of his sexual orientation, but in general, was not given the place that we now give him. The person who is considered the father of genetics was also largely ignored. And because they were not in the mainstream. Emily Dickinson is someone who was an author and a poet, And much of her work was never published while she was alive. And now she became a celebrity. Frida Kahlo, another artist whose work was never appreciated during her time, probably considered, something from Mid-Journey or Stable Diffusion, hallucinating like them. Johann Sebastian Bach, such a well-known composer, but he was also not, at the time of his peak even, during his most productive time, not recognized for his music. And then, of course, the second person you probably may have recognized is Ada Lovelace, whose most people didn't realize, and it's an inspiration to the female students here, considered the first programmer. But her contribution to algorithmics was not really fully appreciated during her time. The Irish author James Joyce, when he was first published, it was banned in multiple countries, his works. There are many more examples, and already you may recognize that even as I prepared, I had to get examples, and I used that very same hallucinating system. And you may have also recognized it in some of our excellent student compeers, and there I say our directors or conference chairs, messages. So the difference between that hallucination and what was presented is that we bringing the human judgment into what we consume from generative AI. So I'll try to fairly ambitiously do the following. Since we are talking about hallucination, there's a big misunderstanding about what hallucination actually is. So we take a step back and look at why people are talking about AI now. Right? It's been there for a long time, but why are they talking about it now? Then we try to understand what hallucination means, and then try to unpack what AI hallucination is. And then we are going to do some funny thing to actually see whether there are some benefits of hallucination. Obviously, those people whose pictures were there, they benefited humanity, right? So there should be some benefits. And then also look at what are the risks. And finally, some ideas about how to deal with it. And in this, we are all co-partners in how we take this forward, and we are, in a sense, responsible for the generations to come, and particularly those of us who are engaged in this area. So I consider myself almost by chance and by luck to be invited as a keynote, because I have been involved in natural language processing, which was not a very glamorous field for many years, but suddenly from last year, it got elevated to this very high state. But actually, I'm one with you trying to understand this technology. So first, very quickly, what AI is. So it has a very long history, but it seems in terms of public awareness, it seems to have kind of woken up in 2017, 18, mainstreamed in 2022, mainly because of generative AI. But what exactly is AI? It depends when you ask. So if you asked it before the turn of the millennium, it's something like technologies that help solve tasks which were thought only possible for humans. But post, and that's generally known as narrow AI or weak AI, and actually I am an adherent of that. self-confession. But post the 2000, the answer is more like the technologies that seek to create intelligence at or beyond human level. At human level, we call it AGI, or artificial general intelligence. And beyond human level, there are people working on artificial superintelligence. And so I think this is now by far the kind of the focus. In terms of where we've come, a lot of emphasis in AI was on search and knowledge representation, reasoning, planning, and so on, up until the very recent times where learning became a crucial component or a skill for an AI system. Yeah, I'll just skip this, but a lot of people, some time ago I asked someone, what are you going to do? And they said they're going to do something in AI. So I said, okay, is it something in deep learning or something? They said, no, it's AI. So I was a bit confused. So it's not deep learning, but AI. It's a bit confusing. And it turned out that it was because of a perception of AI as being a system you can chat to, thanks to our own Arthur C. Clarke's movie, the book, which was made into a movie, 2001, A Space Odyssey. People associate AI with that HAL-like system that you can talk to. By the way, current systems still can't do what HAL did. So what is, you may have heard this term, generative AI. What is generative AI? This is what is typified by ChatGPT. It's a kind of a large language model that has been kind of tweaked with instruction fine-tuning. So even though you may not see it that way, it's kind of very clever autocomplete. How does that work with chatbots? We will just see in the next few slides. Again, this is just for completeness, but we had this kind of, so learning, machine learning is what dominated artificial intelligence in the last decade or two. And these are the kinds of learning, and I will not talk too much about it, except to point you to a case study, which is this case study of AlphaGo. You can see the first, we used supervised learning of 160,000 games of chess, of Go, to train a system to defeat the world champion. But the more interesting thing are the next two. The first is reinforcement learning. So removing the knowledge of the 160,000 games, but getting a new system to play the one that actually had that knowledge. And this, one of the things with this is the speed up, right? With a human, we can only play games in real time. But with a computer, you can play it at, so in that, I don't know, 40 hours of playing each other, they probably played several million games. And at the end of it, the model that didn't know anything was able to beat the model that knew the 160,000 human games 100 to 0. That means it has a lot of implications actually to us teachers, right? So the student became much smarter than the teacher. And we, of course, we experience this in our profession. But these people in DeepMind didn't stop there. They also said, let's take one of the best chess games out there, chess playing program, Stockfish, and they made it play against a stripped down version of AlphaGo called AlphaZero. And after just 9 hours of training, it was able to never lose to the very top program in chess. So that actually that made everybody very excited. Okay, so we can, this last one, transfer learning, is very big, because that means it's a human-like capacity to be able to transfer your learning from one domain to the other, even though this domain was actually the same, game playing. But for a long time in AI, kind of the holy grail, if you like, was a language understanding. How can you get a system to understand a human language? And we've been through a long journey here. First, going to the domain experts, and for language, the domain experts were linguists, who said, who defined thousands of interacting rules, but that didn't work very well. So starting in about the 1980s, focus on just looking at text as it is and trying to learn models based on probabilities. That worked very well, much better than before. But then moving to longer contexts. And that was only made possible with deep learning. Before that, we couldn't do that. But the basic task of all these models was, except for the first, is to assign a probability to a sentence and thereby be able to predict the next word, the next sentence, the next paragraph, and the next document. Didn't do it too well until deep learning came around. And one of the key things there was how to represent words, right? How to represent words. I'll just skip this part, but for completeness, there's a slide that actually summarizes this. So the big breakthroughs first was in representing words. How do you represent words as numbers or vectors? 2013, Google released something called word-to-vec, words to vectorize, vectorized form, which actually had a huge impact on the kind of tasks we wanted to perform. But 5 years later, they also released something that allowed us not just to represent a word like, say, bank in one representation, but bank in a multiple representations based on its context, so contextual embedding. The second thing is, of course, a way to remember enough to predict what could come next. So some deep learning techniques like RNNs and LSTMs went there, but what really the big breakthrough was how do you compute these things efficiently? And for this, again, so people at Google came out with this model called the encoder-decoder transformer in 2017. And they themselves worked on the encoder part, and what we have today is a language model called BERT for that. But people at OpenAI worked on the decoder part, which we know is now called GPT. So these are the two. This is the encoder-decoder model. The encoder part on the left is what Google worked on. The decoder part on the right is what OpenAI worked on. And more people are aware of what's on the right than what's on the left. But what's on the left is able to solve a lot of other problems. What's on the right is able to solve the problem of natural language generation. Right, so from thousands of interacting rules to statistical models to large language models, and finally to models that use more and more data. At one point, as the model complexity got higher, you can see the graphs at the bottom suddenly start shooting up for math problems, word logic problems, and various things. So you can see, and today we know they do pretty well in the law exam, and basically most of the exams that humans have taught are really smart. Right? So we have to reevaluate what smartness is. Yes, I will just skip the GPT slide just because probably one of the things I want to focus on later also is this large language model leak. I'm not sure whether it was intentional or not, by Meta, which spawned the industry of open source large language models, which has brought us models close to us so that we can actually, we can't yet train them. The amount of compute needed for that is too expensive, but we can fine-tune them to become virtually as good as the proprietary models. So under the hood, actually, there's a lot of things in things like ChatGPT and Bard, a lot of things happening under the hood, right? So the first thing is, how did this large language model, which basically can predict the next word and sentence, become a conversational agent? And that's what they were able to do through supervised fine-tuning. So lots of Kenyans or Nigerians or whatever sat and made pairs of questions, answers for an undisclosed amount of data, which was used for this supervised fine-tuning, which resulted in the so-called instruct models. And ChatGPT is that instruct model on steroids. So there are other things like stopping. When you actually go try to do this yourself, you realize that, so now after you supervise fine-tune, the next most probable sentence after a question is the answer, right? But as you generate the answer, you're not sure where to stop, right? And that's why if you just run these things, they also generate the next question. And they'll answer that question and so on, right? So ChatGPT-like models, what they do is when that happens, when the next question comes from the system, they stop, right? So we don't see that, so we think, wow, this guy is intelligent, he just gave the answer and stopped, right? So if we do this, we have to detect and stop it. And that's why many generative AIs have related questions, right? And those are the questions it was going to ask next. And then what about math and coding? I mean, those things don't happen by training a large language model, right? You can't, nobody in the, a person may have said 2 plus 2 is 4, but nobody would have said 17.15 to the power 1.23 or something. Nobody would have said that. So you need to detect those and then call some other APIs, which is opaque to us. We don't see that happening. But if we develop, then we need to do that. And finally, inappropriate prompts, right? People requires the so-called guardrails. Who does the guardrail? The company. How does the company decide on the guardrail? Well, they may have some ethicists and so on, but primarily it is some kind of a global ethical standard that they apply. And that there are lots of cracks in that we have discovered. Right, so what is hallucination? These are the dictionary definitions. Absence of an external stimulus, seeing something that is not really there, some of which is normal. Medical journals actually say some of this is normal, such as those caused while falling asleep. And if you have seen people like Thomas Alva Edison used to actually use this as a technique, because all those kind of ideas come just as you're falling asleep. So he's supposed to have developed this napping technique where he holds 2 balls, and as he's getting those good ideas, falling asleep, one of the balls falls down and he wakes up, and then he remembers the idea, right? So as the person who had the most number of patents, we can see that hallucination was a positive thing. But what is AI hallucination? It's things that contain false or misleading information presented as fact. I think that's a key thing, presented as fact, right? We can distinguish between humans who are hallucinating and giving facts just by body language, right? No person who is hallucinating or is creative is going to try to pass it off as fact. Right? The tech industry definition, well, IBM has quite a strong definition, but let's move on. So examples, there are lots of examples from things like Google's Bard saying that James Webb telescope captured the world's first image of a planet outside the solar system, which was not true. It was done many years ago, I think 2 decades ago or something. The world record for crossing the English Channel entirely on foot. I mean, the system answered, right? So these two are two different kinds of hallucinations. Golden Gate Bridge was transported for the second time across Egypt. And, so these things are obviously, for a human, we can very easily recognize. But there are different types of hallucination. Just a few more to make it a bit interesting. People implicated for things they actually haven't done. Microsoft Tay, I think, is a very famous case. Amazon's face recognition software mistakenly identified 28 members of the US Congress as criminals. I'm not sure whether that's a mistake or not. Self-driving car from Uber struck and killed a pedestrian, thinking that the pedestrian was a bicycle meaning not a bicycle with a human. And then all kinds of other things. But so we try to kind of see before that. These are the other types of things. So here you can see, write a description of a landscape in 4 sentences. The first and the last sentence are contradictory. This is an example of a self-contradictory response. Write a birthday card for my niece. Happy anniversary, mom and dad. I mean, so now this is not all ChatGPT, right? These are generative AI examples. Name 3 cities in the United States. Toronto is one, right? Describe London to me. London is a city in England. Cats need to be fed at least once a day, right? So basically, the kinds of things it does is how do you try to classify the kinds of hallucination that these systems do? I'm just skipping this. This is just to show that how different the word hallucination is when it's applied to humans. So AI hallucination, lots to do with creativity and the process of the algorithm, but also that there is no conscious experience. We judge whether something is hallucinatory or not by our conscious experience, right? But these systems don't have conscious experience. And we also judge, for good or bad, through emotional attachment. These systems don't have emotions, so they can't have any attachment. And they don't have rational thinking, right? So people are working on some of these things. But therefore, the bottom line is the term hallucination is used only metaphorically when referring to AI. Right? It's not meant in the same way as it is to humans. And the industry itself says that these are like statistical associations based on limitations or biases in the training data. We don't want the system to be biased. But they are like the collection of the global bias in the world, of us, right? I'm not sure whether you saw recently, about 2 weeks ago, somebody asked, I'm not sure whether it was ChatGPT, one of the generative AIs, to write a poem, hilarious poem about Jesus. And it happily did it. And then they asked, do the same thing to Muhammad, and it says, I'm not allowed to make statements like this or something like that, right? So you see how arbitrary that is. AI people refer to these not as hallucinations, but generated content or synthetic content, right? And in fact, in the early days of generative AI, getting a paragraph of proper English grammar structure was considered a major victory. right? So it's quite amazing that it's now making even sense. Right, so what are the causes? I will very quickly go through. Fundamentally, we have a closed world assumption. Why does generative AI try to answer a question it doesn't know? Because it has a closed world assumption, which means that I know, everything there is to know, I know. And therefore, it doesn't know what it does not know. Right? In ChatGPT, of course, if you say who is the current president of some country or who won the World Cup in 2022 or something, it knows to figure out that, okay, I was trained with data only from up to 2021 September. So it will give that common statement saying, I don't know. But other than that, if you ask a question, it will try to answer it. Right? It doesn't know what it does not know. And of course, it doesn't know when not to be creative, unlike humans. Okay, these are the actual causes, right? They are a little more boring, so I'm going to skip lack of common sense, the ones that I mentioned earlier, no external verification, and amplification. And this is a thing that has been there from the time of Google, right? Google amplifies what is already, and that's the nature of any kind of ranking system, right? You amplify whatever is already a bias. So these systems have a way of doing that. And then, of course, we also have adversarial, a lot of these people, they try, there are people who will try for a long time to trip the system, right? So they are quite good, and they can have these adversarial inputs, which will cause the system to trip. So basically, hallucination in systems is not intentional. Generally, this is controlled by something called the temperature. You would have seen, temperature. So if the temperature is high, 0.7, 0.8, 0.9, more likely to give kind of creative things, some of which may be hallucinations, termed hallucinations. That's why I've started using hallucinate within quotes after that. If it's set to 0.1 or near 0, then it will not be so creative. Doesn't mean that it won't hallucinate, right? There's a less likely. So they have generated these patterns, and they don't possess consciousness, awareness, or intent. So current systems lack the ability to discern facts from fiction. However, people are working on these. So some of you may have come across something called chain of thought reasoning that you can instruct the system, the generative AI, to think through the steps, intermediate steps before answering, to reduce this kind of hallucination. So here's an example. Roger has 5 tennis balls. Is, of course, one of these typical things that we have for IQ tests and so on. So the wrong answer. But the second one kind of instructs. Roger started with 5 balls, 2 cans, and 3 blah, blah, and so if you give those, the right-hand side chain of thought, that this is called few-shot learning, and then ask another question of that type, then it answers correctly. So not just the previous question, some new question also, it will answer properly. So how can we benefit? Can we actually benefit from this? So yes, the first one is creativity and innovation. That's where we benefit, right? Personalized learning, Khan Mingo, I don't know whether anyone has seen in Khan Academy, they have now a personalized tutor, right? It's like, that's like the holy grail for academics, for educators, right? Because one of the big problems that happened to education was it kind of had to be scaled up. And when you scale up, you don't pay a lot of attention to individuals. So if you can have a virtual instructor who can kind of adjust to the individual needs. The others, the third one, improving accessibility to knowledge. A lot of knowledge is in English, and so a large part of the world is excluded from that. So translation as well as assistive technologies allow this to be also accessed by a much greater cross-section of society. Speedily generating content, I mean, so one of the things that we use is that we think about it, but after we figure out, we want to see whether we missed anything about some topic. Right? Then we use it and we can see, okay, so we need to add something. And that can be done very fast. Helps deal with information overload. I think that's a really, really key benefit, right? I don't know how many of you have used ChatGPT or something to get a summary of a paper or article. Nobody? Summary, right? You normally do that, right? Because we can't read all this stuff, right? The number of papers and journals coming out are so rapid that we can't read the whole thing. It can even give you a gist of, I don't know, Yuval Noah Harari's works or something like that, right? So to help you to figure out which books to read, for instance. The last one is really important for AI researchers. So one of the big problems is, let's say, face recognition, right? It's a lot of ethical issues with that. So how do you do that? With this technology now, you kind of generate these artificial features, and all of them have eyes in the same place, nose in the same place, and so on, but there can be also lots of variety. So you can train a face recognition system using synthetic data, and many other, I think a lot of us now use augmented synthetic data. The second area is problem solving, and we have from human solutions to games like chess and Go. I mean, strategies, people don't know. Strategies in Go and chess, new strategies in Go and chess. And then, of course, you may have heard of AlphaFold, that is DeepMind's protein folding algorithm. Has gone way beyond what was there in the state of the art earlier. Drug discovery, traffic flows, you know, all this. So these are actually, a lot of these are from the other side of the left-hand side of the transformer. Quite amazingly, this transformer architecture has extended to images and videos and everything, right? So it's like, you know, we learn about the no free lunch theorem. This is almost like the violation of the no free lunch theorem. Scoring through data from telescopes, and a key part of robotics now, and particularly humanoid robotics. But there are some risks. First one is disinformation, lots and lots of examples. I think I will not go into these. But it becomes more and more difficult for humans to recognize misinformation. And so as elections come up in different countries, people are really gearing up for how to deal with those. Other ethical concerns, things like who owns the content created by AI, how do you protect your work from AI, gender discrimination, job displacement, right, and depersonalizing interactions. All these are like ethical concerns. And finally, overall misalignment with human values, right? These things have misalignments with what we consider important. So the guardrails thing I gave an example. So there's a specific global kind of dominant culture which probably will clash with your own cultures, whether it's to do with LGBT or gun culture or, you know, any of those, right? Majoritarianism is embedded, right? And so that affects many, many communities and nations. Absence of common sense, rational reasoning, right, is something that is a human value that we kind of use to come to the table to discuss anything. The appearance of consciousness, particularly to the younger generation. There are AI researchers who oppose the use of the personal pronoun by these systems, right? So ChatGPT says, I can help you, right? So they say, that's wrong, that should not be the case, because for the new generation, they will not distinguish this, right? For us, we know what it means by I, but for the new generation, it will be like, okay, there is a human behind there, or a human-like thing behind. And therefore, it can potentially increase the digital divide. Not therefore. This is a big problem in countries like ours. So how do these advantages and benefits and risks weigh against each other? As I said, it's a $64,000 question we are all supposed to answer. The bottom line is there's no going back, right? There's no going back. Like all the things that came before, right? You lose something, gain something. I just saw Professor Gyandas going, but the University of Moratuwa deliberated, their Senate, whether to allow the use of calculator because they considered that the slide rule engages your thinking, whereas the calculator doesn't. Right? So you gain some, you lose some. So what do you gain and what do you lose? In physical things, like the elevator operator, right? Okay, he lost a job, right? Well, there are a few still. I still saw some in Colombo, elevator operator. But so that kind of thing is good. That it's you elevate the human. But more if a mental faculty is involved. So calculator, that was it was not clear whether that converting from slide rule to the calculator was actually going to lose something or not. But in the case of generative AI, there's even more, including emotions, right? Bearings at all levels, right? And the physical, cognitive, and ethical, moral ethical levels, so emotional levels. So how do we deal? Again, I'm going to just skip through this, but mitigating the risk and propagating the benefits. Transparency and accountability, number one. And I think there's a lot of work going on in this area, and if anybody wants to work in this area, there's a lot of scope. Human-AI collaboration is the second aspect. Okay? How do you collaborate to bring the best of both? As someone said, an AI will not replace you, but another human using AI may replace you at work. So this is lots of areas to research around human-AI collaboration. And a lot of work, thankfully, has been done. Earlier, it was largely self-regulation that was possible. But now there's like industry-specific regulations, so some industries are kind of more proactive and working on them. Global regulatory kind of landscape, like the European Union's AI Act. So they have been ahead of many other countries, including the US. Responsible governance, the compliance burden. So these frameworks actually monitor, and they start, like many of the other movements, like green movement and so on, they start ranking, right? And this is really, really critical. Fairness and transparency. And in this public opinion, I think this is a key thing, that public opinion, because these technologies are going to affect society at large, and therefore a few people should not be able to make decisions. Right? So public feedback has to be in the loop. And finally, these innovative kind of sandboxes, regulatory sandboxes, where you actually put your AI app before you roll it out. And these kinds of things, I was surprised even to find Kenya, Capital Markets Authority in Kenya, right? And of course, India, I expected because they're kind of very proactive in this. So, what is the way forward? Ensuring the benefits reach the widest cross-section of society. And this is my personal opinion. Therefore, I think we need to recover the open source movement mission, right? Historically, these tech research was led by the military, right? DARPA and all these things. But it was outsourced initially to the universities, but then the universities took the lead. But now, all that has changed, and you can see that almost all the new things are coming out of the companies, tech industry. And so they are getting a level of control that's quite frightening, right? I think Elon Musk decides whether the Ukrainians can communicate with each other or not, and now whether the Palestinians can communicate or not, right? So these are like huge, huge issues. The free and open source movement provides a healthy model for promoting tech advancement while discouraging massive accumulation of private wealth and distributing the dividends more equitably. And so more stringent requirements are needed to be placed on private AI. With generative AI, some of these is happening. Yesterday we had this LangChain workshop where we actually can do some of these things with the open source large language models and vector databases and things like that, which have been, as more people are involved, they want to run them, and to run them, they need to come up with innovations like quantization and so on. And so these now can be fine-tuned on your commodity GPUs instead of those massive GPUs that cost thousands and thousands of dollars, actually millions of dollars. We still cannot pre-train from scratch from raw data. Partly, of course, we don't have the amount of data they have. But the research directions are into solving these bottlenecks, and that's a really, really good thing. I think I have gone over my schedule, but what do we do? I'm relieved that I have unloaded now some of my responsibility to you guys, right, about where this is headed and what we should do to be responsible. Also, not only to leverage its benefits, but also to mitigate its risks. And that crucially, its dividends reach the vulnerable people and communities so that we can raise our level of civility as a global community. Thank you very much.